In this video, guys, we're going to be proving the first kinematics equation, which is velocity final equals velocity initial plus acceleration times time. Now, keep in mind, guys, that this equation can only be used when the acceleration is constant. So we will be using a little bit of calculus. So if you're in the algebra-based physics course, you may want to watch one of my other videos, which will actually prove this equation using just algebra. Okay, so first off, we know that the acceleration is the time rate of change of the velocity. So remember from calculus that rate of change is another way of saying derivative. So acceleration is the first time derivative of the velocity, which is just saying that the acceleration is the time rate of change of the velocity. So what we can do, this is a first order linear differential equation that we want to solve for velocity. So what we're going to do, we're going to go ahead and multiply both sides by dt. So we have that dv is equal to the acceleration times dt. And then we're going to go ahead and integrate both sides. Now remember that the acceleration is a constant, so we can actually pull it out of the integral. So we have acceleration times the integral of the exact differential dt equals the integral of the exact differential dv. And this is an indefinite integral. You can also do this derivation with definite integrals, but I'm going to just do it with indefinite integrals. So the integral of dt is just t, so you have at plus a constant equals, and the integral of dv is just v plus another constant, but that constant can just be absorbed in the c that we have on the left-hand side. So we have v, right? And this is really v of t because velocity is a function of time. So what we can do to solve for the constant c is we could actually substitute in time equals 0. So if we do that, we have velocity at 0 seconds equals a times 0 plus c. So evidently the velocity at 0 seconds is just the constant c. Now we can give this a name. We can go ahead and call that v sub 0, which just is pronounced v naught. And that's just the velocity at time equals 0, the initial velocity. So we could now write the velocity as a function of time as at plus v naught. Now most textbooks actually write v of t as v final. So we could rewrite this equation as v final equals v initial plus acceleration times time, and that was the equation that we wanted to derive.